ceramic engineering.
Oh yeah, don't they make rubber duckies?
Like the science of making toilet bowls.
I have no idea.
They make pottery too, very nice pottery.
It's amazing to me how many young people, including college freshmen majoring in engineering, don't know what ceramic engineering is. I'm Alex Clare and I'm a ceramic engineering professor here at the New York State College of Ceramics at Alfred University. My goal is to show you how cutting edge the science is. Smashing, really. Got it. Know why your head won't be slashed to bits by a broken car window? That's because ceramic engineers invented tempered glass about 100 years ago. When it does break, it breaks into these little pieces with relatively smooth edges rather than these sharp shards. So, why is tempered glass so hard to break? Well, normal glass is full of microscopic little surface cracks which make it easy to break. But we've found a way to close those cracks on the surface. We cool the outside of the glass at a different rate than the inside of the glass, essentially squishing the atoms together on the surface, making it incredibly strong. Thank you. Now wait and see what happens to soda lime silica glass when you temper it, not with heat this time, but with chemicals. This jar should have smashed into 1,000,000 bits, but we gave it a bath in molten potassium nitrate. The big potassium ions are in the solution and the small sodium ions are in the glass. The small sodium ions get sucked out of the glass and into the solution and are replaced by the big potassium ions, and in doing so they squeeze together all the cracks in the surface that made the glass weak. Chemical ion exchange does make glass stronger, but it's a really slow process. There is a way to speed it up. Researchers here at Alfred's College of Ceramics found out that sound waves actually speed up the ion exchange process.
Well, we found that music or sound with the higher frequencies seems to work better. And we think that it accelerates the ions to jump faster.
Just think! The next wave of ceramic engineers will be making ultra-thin, ultra-strong window glass that will stand up to me. The windshields of the planes you fly are not only strong, they've got an extra ceramic coating on the glass that keeps them clear of fog and ice. What if you could coat a whole airplane with a ceramic?
Houston now controlling the flight of Endeavour.
You'd have something like the space shuttle. Thanks to the shuttle's ceramic tile shell, it can really take the heat of flying into the upper atmosphere and back without burning up. You see, ceramic materials are not only strong, but lightweight, corrosion resistant, and have very low thermal conductivity. This is a real space shuttle tile. It's only glowing at a few hundred degrees right now, and heat on re-entry is 10 times higher than that. But thanks to this thin ceramic tile, the astronauts inside the shuttle are well protected. Remember this club? Oh, ah! The shaft is made out of a strong ceramic called carbon fibre composite. This material actually gets stronger as it gets hotter. Therefore, you could use it to make a plane that would cruise at the height of the space shuttle. Ceramic materials are not plastics, and they're not metals. Ceramic materials are chemical compounds such as oxides and halides. New materials designed literally from the atom up. Here in the lab, ceramic engineers create the materials that enable other engineers to do their work. As a first-year ceramic engineering student, you really dig into the basic building blocks of ceramic materials. We call this the Mud Lab. Here you learn the processes used to make everyday ceramic articles, like plates and cups. You might call ceramic engineering a form of high temperature chemistry. We call it atomistic engineering, putting materials together, one atom at a time. Welcome back to the Ceramic Shopping Channel. It's the strong covalent bonding in ceramics that make them really tough, like this ceramic hammer. And these ceramic scissors never need sharpening. And real or fake, gemstones are ceramic. Why don't you zoom in on this bear? Doesn't he look beautiful? We can make you a diamond that's just as good and just as tough as the real thing and a lot cheaper. So there's only 400 left. Phone now, 1-800-CERAMIC. Call me. You know, if these car engines had been made out of ceramic materials, then they would have lasted a whole lot longer. You see, ceramic materials can get really hot without melting. So if only these engines were made of ceramic, you would never crack an engine block, and you'd never melt a piston, and you'd never wear out a camshaft, and you'd never even need a radiator to cool the engine. Plus, you'd be able to run your engine so hot, you'd burn gasoline much more efficiently, cutting way down on global pollution. But that's way in the future. Right now, ceramics are already helping us to breathe easier. The key anti-pollution device in cars is the catalytic converter.
Inside the metal canister of the typical converter, you'll find a cellular ceramic substrate coated with a combination of precious metals,
which breaks down hot gases into harmless chemicals. We all know that ceramics make great insulators, like this power line insulator and this ceramic spark plug cover, but did you know that ceramics make superconductors? Back in the 1980s, we thought we'd found the perfect conduit for electricity. It was a ceramic superconductor made of yttrium barium copper oxide. At the temperature of liquid nitrogen, it offered zero resistance to electrical current. Nothing would stop the electrons zipping down the wire. As it turns out, their magnetic properties are pretty wild too. Imagine this magnet as a bullet train floating on a cushion of magnetic field. The Japanese are working on this. There are metallic superconductors, but they have to be a lot colder than this to work. Liquid nitrogen is cheap and plentiful, making ceramic superconductors commercially viable. But here's the problem. It's really difficult to make a wire out of a ceramic. You could put a ceramic coating on a metal wire, but that raises a whole bunch of other problems. Who knows? Maybe you'll be the one to help us solve them. I'm going to be late. I just know it. Look at your watch, dummy. Oh, by the way, the quartz crystal inside every quartz watch in the world is a ceramic too. It's called a piezoelectric ceramic.
Piezoelectric ceramics means pressure electricity. It's one of the neat kinds of electricity. It lets us do things without moving parts. We can take a fan like this, piezo blades, no motor inside, and just by applying electric field, get motion or pressure. We can also go the other way and go from pressure into an electric signal. So we take air pressure, blow on it. Piezoelectric ceramics are in all kinds of everyday things. Autofocus cameras, Navy sonar systems, and they make great detectors.
Imagine if we could install them in all the bridges and highway overpasses in the world. The piezoelectric ceramic could detect subtle changes in pressure, meaning potential failure of the structure before anybody gets hurt. Changing the temperature of a ceramic can change its voltage too. Night scopes and thermal imaging cameras rely on this technology, called pyroelectric ceramics. Texas Instruments developed this night vision system for the troops fighting in Desert Storm. Don't want to be seen? Lining up charges in an electric field can give you some privacy. This privacy glass can be either opaque or transparent with the flip of a switch. It works by suspending liquid crystals in an emulsion between two layers of glass. A conductive coating inside creates a positive and negative field. Apply a charge and the crystals line up in one direction, allowing light to pass through. Turn it off and the crystals return to their random unaligned state, blocking the light. Better TV viewing through ceramics? Why not? Optical glass fibres as thin as a human hair can carry light signals with billions of data transmissions per second. What if we replaced electric TV cables with glass fibres? There'd be thousands of channels and terrific interactivity, and you could order from the ceramic shopping channel 24 hours a day.
That's just as good and just as tough as the real thing and a lot cheaper.
Most computer systems already use fibre optic networks to send data. But if computers also used optical integrated circuits instead of electronic ones, they'd work at lightning speeds. Sometimes you want to use optical fibres to actually look at something. You can bundle them together and look inside the body, like with an endoscope. Add another fibre optic that carries only infrared light, and you can do laser surgery deep inside the body without too much trauma to the patient. Bioceramics is an exciting field of ceramic engineering. It involves the interactions between ceramic materials and living things. Until now, that has meant finding replacement parts for people. Sorry. Total hip replacement, for example, is a fairly common operation for older people.
The deformed ball at the end of your thigh bone is removed. The stem with the new ball at its upper end is then inserted into your thigh bone.
But young people who are more active suffer from disease and bone loss too, and they need artificial hip joints that will last a long time. Thanks to ceramic engineers at a company called Xylon, a group of Alfred graduates by the way, the ceramic head on this hip joint is tougher and smoother than the metal kind. So it lasts a long time and it doesn't wear down the hip socket that it sits in.
Okay, now put your left foot on the floor.
Ceramics do well inside the body because they can be made to be inert.
Okay,
These materials have such strong covalent and ionic bonding that they're completely satisfied and don't want to bond with anything else. So the body doesn't reject the material. But you can design a ceramic that will react with the body. Here at Alfred, we're making something called a bioresorbable glass, and it could turn out to be a real breakthrough cancer treatment. Bioresorbable glasses, which look like chunks of metal when you roll them out, are designed to dissolve inside the body. They also have tiny magnetic crystals inside, and we believe you could grind the glass up and inject it into tumours. Here's the theory. This is a healthy brain. This is a brain with a tumour. We know that we can get rid of the tumour by heating it up just enough so as not to harm the healthy tissue around it. So we can inject the glass ceramic into the tumour and then subject the patient to a weak oscillating magnetic field, and the tumour heats up and eventually dies and goes away, leaving us only with the glass ceramic, which dissolves harmlessly away in the body. Imagine this. We could make bioceramic coatings that are bacteria resistant. You could coat surfaces in kitchens, hospitals and bathrooms with this stuff.
What? You mean I'd never have to scrub that ugly grout again?
No.
And I'd never pick up anything nasty off of a doorknob?
No.
And I'd never have to scrub them bowls back there?
No.
Hallelujah! Saved by ceramics!
So now you know what to say when someone asks you what a ceramic engineer does. What do we say? We're inventing the future! And I'll see you in Mudland!